Welcome back, focused learners. Today, we are strapping in for something incredibly high stakes. Imagine a Formula One race for a second, right? The cars are unbelievably fast. The drivers are highly skilled. The engines are roaring. But here is the secret. Championships aren't just won out there on the track. They are won in the pit lane. Every single second counts. Efficiency, precision, and systematic execution, that is literally the difference between taking first place on the podium and suffering a total, catastrophic engine breakdown. Well, listen, that is exactly how you need to treat your Cambridge Computer Science examinations. Whether you are battling through syllabus codes 0417, 0478, 0983, 0984, 2210, or what we are heavily focusing on in today's explainer, the 9618 AS and A-level course, the pressure is immense. The timer is always ticking down. So consider me your pit crew chief today, and I am the strategist. This explainer is your ultimate pit crew strategy for completely conquering the 9618 exam. Specifically, we are zeroing in on section 20.1, Programming Paradigms. Look, this is undeniably one of the most conceptually dense, heavily penalized sections in the entire syllabus if you get your timing or your structural approach wrong. Examiners are ruthless here. So what are we going to do? We are going to entirely transform the way you extract data, the way you analyze code, and exactly how you write your answers so that you maximize every single mark in record time. We are leaving absolutely nothing on the table. Are you ready? Let's get the engine started.
Okay, let's dive into this massive question. Why do so many smart, capable students completely crash and burn on Section 20.1, Programming Paradigms? To understand this, I want to introduce you to two archetypal students we see in the examiner reports time and time again. Picture a split screen right now. On the left side, we have Alex. Now, Alex works hard. Alex has basically memorized the entire textbook. When Alex sees a question, they overload the answer with raw computer science facts. They'll write out perfect dictionary definitions of object-oriented programming, declarative programming, procedural programming. But here is the fatal flaw. Alex provides absolutely zero analysis of the actual scenario given in the paper. The result? A heartbreaking sea of red pen marks. All that knowledge wasted because it wasn't applied. Now, on the right side of our split screen, we have Sam. Sam is different. Sam feels the intense pressure of the clock ticking down. Panic sets in. Sam rushes through the paper, completely skimming the prompt, and entirely misses the specific command word requirements. Sam doesn't realize there's a massive difference between an evaluate command and a describe command. So Sam drops massive marks despite actually knowing the underlying concepts really well. Listen to me carefully. Both of these approaches are guaranteed to cost you a top grade. Section 20.1 is not just about regurgitating what a programming paradigm is. Anybody can do that. It is about proving to the examiner that you can select, justify, and apply that paradigm to a completely unseen, complex problem under immense time pressure. It is the ultimate test of your algorithmic thinking.
Now, I want you to really absorb this quote directly from the principal examiner report. It literally says, candidates referencing cross-topic connections achieve significantly higher marks. This, right here, is the absolute insider secret straight from the very people who are grading your papers and deciding your future. The theoretical architecture of programming paradigms rests on precise definitions, yes, but far more importantly, it rests on causal relationships and seamless integration with other areas of the syllabus. Raw knowledge simply isn't enough anymore. The examiners want to see connected structural reasoning. For example, if a question asks about a declarative paradigm, top-tier students don't just define what it is, no way. They connect it to artificial intelligence applications or complex database querying or specific data structures you learned way earlier in the course. You have to prove to them that your brain isn't just a dusty filing cabinet of disconnected facts. You have to show them it's a highly tuned racing engine where all the parts, the pistons, the gears, the exhaust, work together perfectly. So here is our race map for today's explainer. First, we just covered the paradigm problem. Next, we'll hit the core foundations. Then we dive into the procedural framework. After that, we'll look at track hazards. And finally, we will hand you the blueprint. Let's transition straight into Section 2, Core Foundations. The Cambridge syllabus explicitly states that top-performing students exhibit connected, conceptual understanding that is completely transferable to unfamiliar contexts. Let me translate that. They prioritize analytical depth over superficial breadth. They don't want you to know a little about a lot. They want you to know exactly how to apply core concepts to brand new situations. So how do we structure this depth? We use the PEEL framework, PEEL, Point, Evidence, Explanation, Link. Think of this as the reinforced chassis of your race car. When you face a high-value command word like analyze or evaluate regarding a programming paradigm, you absolutely cannot just list facts. You have to build an argument. First, you make your point. For instance, you declare, the object-oriented paradigm is most suitable for this application. Boom, clear and direct. Second, you provide evidence pulled directly from the exam prompt. You say, because the scenario specifically requires multiple instances of independent player characters. Third, you give your explanation of the computer science theory. You write, objects encapsulate both state and behavior, preventing data corruption across these simultaneous instances. Finally, the crucial part, you link it all back to the core requirements of the question. Therefore, OOP provides the most secure and modular approach for this specific game engine. Do you see the power of that? That PEAL structure, combined with sharp command word decoding, is exactly what elevates an answer from an average, middling grade to an absolute elite tier.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, moving into Section 3, the procedural framework.
I need you to think of this 5-step sequence as your non-negotiable pit stop routine. When you pull into the pit, every motion must be calculated. Step 1. Deconstruct the question. What is the actual command word? Are they asking you to compare, describe, or evaluate? If you misread this, you are driving in the wrong direction from the start. Step 2. Extract the data. Pull the relevant constraints right out of the scenario. Are we dealing with binary representation? Are there specific memory boundary conditions mentioned? Grab those facts. Step 3. Select your analytical framework. Are you going to use the PIEL method we just talked about to structure a comparative analysis? Choose your tool before you start building. Step 4. Execute with clear notation. Guys, this is where so many students bleed points. Write your working out. Show the examiner the math, the logic, the trace tables. Step 5. Present with correct terminology. Do not ever say it does it step by step. You must say it utilizes a procedural programming paradigm. You have to speak the language of the examiner. Listen, if you skip even one of these steps, it is exactly like leaving the pit lane with a loose tire. You might feel fast for a second, but you will absolutely crash on the next turn. Systematic processing is non-negotiable here.
Let's formally define algorithmic thinking within the context of paradigms, because honestly, it is the high-octane fuel for this entire procedural framework. It requires 4 things: step-by-step problem decomposition, appropriate data structure selection, efficient code implementation, and absolutely rigorous testing. Let's bring our friends Alex and Sam back into the picture to see how this transforms an exam paper. Imagine we step in as their pit crew chiefs and guide them to rewrite those terrible answers using algorithmic thinking live. Alex, who used to write textbook chapters, stops. Instead, Alex decomposes the specific problem given in the prompt, selects the right data structure, let's say it's a 2D array for a grid-based game, and explicitly justifies why that structure fits the paradigm. Boom. Instant points. And Sam? Sam finally slows down. Sam reads the command word carefully, realizes it says evaluate, and applies rigorous testing logic to their answer, proving exactly why a procedural paradigm might fail in a complex graphical user interface environment, and why event-driven is better. If you could see their papers right now, you'd literally watch the examiner's red ink physically transforming into beautiful green check marks. You can see their mark potential surging from a failing 20% right up to 100%. That is the power of the transformation when you apply the framework.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get right into the evaluation and method mark strategy.
Now, what's really interesting about this next concept is the deconstruct, solve, evaluate methodology. This is your higher-order problem-solving loop. You identify the given information, break it into logical steps, solve it systematically, check for reasonableness, and make justified recommendations. Okay, we are going into an interactive workshop right now. Challenge 1. Data scan. I want you to imagine a highly complex computer science data table popping up on your screen. It's showing execution times of different sorting algorithms running under various programming paradigms. I am starting a 60-second visual countdown timer in your mind right now. Go. Scan the data. What is the core trend jumping out at you? Are the functional paradigms performing better under heavy recursion? Are the procedural paradigms suddenly failing and bottlenecking as the data scales up? Time is ticking. You have 30 seconds left. You need to extract that core trend immediately, because in the actual exam hall, you do not have time to sit back and stare. You must ruthlessly deconstruct the data table, solve the comparative question in your head, and evaluate which paradigm is superior based on the numbers. 5, 4, 3, 2, 1. Time's up. If you didn't instantly spot the correlation between data size and execution time across those paradigms, you need to seriously practice your data scanning speed. That is a critical race skill. Let's move to challenge 2. Find the flaw. We are going to look at comparative analysis. A top-tier, good answer highlights similarities and differences using specific comparative connectives, supports each with evidence from the text, and makes justified recommendations. A bad answer, it's just superficial breadth lacking any context whatsoever. Listen carefully to this flawed sample paragraph and see if you can find where it loses marks. Ready? Object-oriented programming uses classes and objects. Procedural programming uses subroutines. OOP is generally better for large projects. Take a few seconds. Where did they lose the marks? What's the flaw? The answer is literally everywhere. There are absolutely zero comparative connectives. There is no evidence pulled from a scenario. It is entirely superficial. Now, let's rewrite it. A much better answer would be, whereas procedural programming relies on the sequential execution of subroutines, making it difficult to scale, object-oriented programming encapsulates data within classes, which allows for significantly greater modularity and security in large-scale enterprise projects. Do you see the massive difference there? The examiner commentary would heavily reward that second sentence because it demonstrates deep structural reasoning rather than just blurting out facts.
This brings us to a massive, flashing red examiner alert. You must show you're working. Listen to me. Method marks will save your life, even if your final answer is completely, totally wrong. If you're doing binary representations, complex calculations, or tracing an algorithm within a specific paradigm, you need to write down every single logical step. Systematic processing is highly rewarded. The examiners are literally hunting for your method. Let's do challenge 3, speed writing. 30 seconds on the clock. Imagine an exam question asking you to justify a paradigm choice for highly secure global banking system. Go. Write one perfect Peel paragraph in your head. Timer is running. Point. High security and data protection are needed. Evidence. The scenario involves sensitive financial transactions across multiple branches. Explanation. We need strict data encapsulation and inheritance to manage different account types securely. Link. Therefore, the object-oriented paradigm is strictly required over procedural to prevent unauthorized state modifications. Time. If you can structure that argument that quickly and explicitly show the working of your logic on the page, you secure those method marks every single time, no matter what.
We are heading into section 4, track hazards, top examiner warnings. Keep your eyes on the road. Cambridge Principal Examiner reports consistently highlight exactly where students drop the ball year after year. Let's rapid fire through the top 3 fatal errors so you don't make them. Number 1, forgetting to check overflow and edge cases. If you're evaluating a program's robustness within a certain paradigm and you completely fail to mention what happens when a variable exceeds its memory allocation, you lose the mark, period. Number 2, ignoring boundary conditions. This happens all the time with arrays or loops. If a procedural array holds exactly 10 items, you must explicitly test what happens at index 0, what happens at index 9, and critically, what happens at the invalid index 10. If you don't write that down, the examiner assumes you don't know it. Number 3, answers not specific to the question context. This is Alex's problem from earlier. If the question scenario is about controlling a robotic arm in an automotive factory, and your answer starts talking generally about a school payroll system that you memorized from a revision guide, you get 0 marks. 0. Rushing through the exam leads to missing these crucial checks. You absolutely have to stay focused on the exact track you are racing on. And finally, section 5. Let's bring it all together into the final blueprint. So, the crucial point is this 3-phase breakdown you see detailed here. This is your ultimate memory hack, your golden cheat sheet for section 20.1, and honestly, for all of your 9618, 0478, and 2210 exams. It breaks down into 3 unbreakable rules that guarantee top marks. First, the identify phase. You must strictly decode the command word and extract the scenario data. The hazard to avoid here, missing those sneaky edge cases and boundary conditions. Second, the execute phase. Apply your step-by-step algorithmic logic and write out your clear, indisputable working using the Peel framework. The hazard to avoid, providing no written working and completely throwing away your method marks. Third, the evaluate phase. Make highly justified recommendations using sharp comparative analysis. The hazard to avoid is a generic lack of context. This right here is your ultimate time management matrix. If you memorize this matrix, your mark potential will absolutely surge to 100%. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by.
I want you to really think about what we covered today. The exam timer is always running, but with the systematic pit crew approach, you control the pace of the race. So how will you adapt your exam strategy right now, today, to secure those vital method marks? Will you finally slow down and decode those command words? Will you use the Peel framework to ensure your comparative analysis has actual undeniable depth? Remember, the difference between a passing grade and a perfect score isn't just what raw facts you know, it's how systematically and efficiently you can prove it to the examiner under immense pressure. Keep analyzing, keep optimizing, and apply this blueprint to your very next practice paper. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.